Welcome to May 20th LeetCode Challenge. Missing number. Given an array nums containing n distinct number in the range of 0 to n inclusive, return only the number in the range that's missing from the array. So we're given this array of n equals to 3. So what number is missing between 0 and 3? The number is 2. Since there's 3 numbers in this there's only missing one number, which is 2. 2 is missing from the range since it's not appearing in array nums. We're given here example number 2, n equals 2, right? Because we have 2 numbers in the array, and what number is missing? We have 0, 1 is missing the number 2. Because 2 is inclusive, 2 is missing from the array, therefore we return the output 2. Given the array nums here, we have basically n equals to 9, so basically 0 to 9 inclusive, and the number that's missing from the array nums is 8. So the important thing we're going to keep track of is the constraints. So we know that the array nums, the length of nums is equal to n. So we know at most we have n numbers and it's inclusive of 0 to n. So therefore we're always going to miss one number. And we know that n could be any value between 1 to 10 to the 4. And that each index or each value of nums is ranging between 0 to n. So meaning that we could have numbers that go between 0 all the way up to n, and at most it's missing one number because all the numbers and nums are unique, right? So we know that we're missing at least one value in this. So could you implement the solution using only linears, extra space, and a constant extra space and linear runtime complexity? The answer is yes. So in order to kind of think about this, if we were missing one number completely and we want to find that number, we could use a bit manipulation to just kind of figure out the numbers as well. But intuitively, if you think about, say, if we were to add all the numbers together and subtract it by, if we were to try to find all the numbers to add together, if you know the series, for instance, all the way from 0 all the way up to n, and you add that all together, say you have something like 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus n. If we know the sum and we were to minus it from the sum of the numbers that we have, then ideally we would find a number in here that we're missing, right? If we were to know the series addition and we were to minus it from the sum of what we have so far, then we would know that the remaining number is the number that's missing. Right? Does that make sense? So if we find the number between 0 to n, we add them all together, we know that, that's a known thing. And then we would minus the sum of all the numbers in the array nums, then the remaining number is the number that is not in the array. And this sum series is actually known as Gauss's formula. Gauss's formula is basically, the equation for that is n times n plus 1 divided by 2, where n is the length of the input nums. And this is the formula that's equal to the following: plus 1 plus 2 plus 3 plus 4 plus all the way up to n. And we're going to use this formula to our advantage right here. So basically what we want to do is find the sum minus that from the sum of the numbers. And that's pretty much it, right? And we'll go about solving that right now. We can actually probably do it in one line. So what we want to do is return the Gauss formula, which is actually the length of nums, so this is n values, right, times the length of nums plus 1 divided by 2, and that'll be integer division, minus the sum of all the numbers together. And then once we use Gauss's formula and we minus it from the sum of all the numbers, then the remaining number will be the number that's not included in the summation of 0 to n. Run this code. 2 seems good. And it's accepted. So time complexity wise is big O of n, because n is the length of nums. We have to iterate through the length, of course. Memory complexity is big O of linear time for extra space, because we store everything inside a integer variable. All right, that is all. Have a great day, guys.